And in this module, we are going to start learning some of the basic syntax for the C# language. There's a lot of information in this module, but we'll revisit some of the topics in this module time and time again as we move through the course. So open up your editor and follow along, because I want to give you some small exercises to try as we move through the module. These exercises get you writing code on your own and storing knowledge about C# inside of your brain. Before we start though, let's look at some requirements for our software. As a software developer, you generally write software to solve a problem for yourself or perhaps for your business. And oftentimes the problem comes to you from a manager or a customer or from an idea that strikes you in the middle of the night. Let's pretend we are working for a school and the boss comes to us with the following requirements for new software. We need an electronic gradebook to read the scores of an individual student and then compute some statistics from those scores. The grades are entered as floating point numbers from 0 to 100, and these statistics should show us the highest grade, the lowest grade, and the average grade. Now, one of the biggest challenges you'll face in software development is taking requirements like this and turning them into code. Really, the code itself is easy. It's translating the requirements from your users and customers and coming up with a good system design. Those are the hard pieces. But when you're just starting with a language, you need to learn the basic syntax and features of that language so that you don't have to think about syntax details and you can focus on these bigger, harder challenges. My advice is always to start small. The way to work with software is to tackle little pieces and little problems and get those little things out of the way so you can see the bigger picture. So for these requirements, let's first focus on the part that says, given a collection of grades, we need to show the average grade. Averaging a collection of numbers will require some math operations. So let's first figure out how to write mathematical expressions in C# and assign those expressions to variables for storage. Something we learned in the first module of this course is that when we execute or build or run this application, we're going to be executing and running the lines of code that appear inside of this main method, which is the entry point for the application. And I also pointed out that the C# language likes to use curly braces to denote the start and the end of different things in the language. So the start of this method is this opening curly brace, and this method, technically the method body that is inside, ends with this closing curly brace. And every start needs an end. That's why it's nice to have an editor like Visual Studio or Visual Studio Code that understands the C# language and can show you when two curly braces match up, either by drawing a line or by doing some highlighting. Now, these significant pieces of code that are inside of this method, each of these are what we would call statements in the C# language. So this code on line 9 is what we would call an if statement. This code on line 11 is a statement that invokes the writeLine method on the console. And something you might have already noticed, and I haven't talked about, is the semicolon that appears at the end of the statement. So some statements in the C# language do not require a semicolon. Obviously, this program is working well without a semicolon at the end of the if statement. And in other places, the C# compiler, that tool that translates my C# language into an efficient binary format, requires me to place a semicolon at the end of a statement. And the idea is that the semicolon will allow the compiler to figure out where one statement ends and the next statement begins. And the rules about semicolons can be a little bit intimidating when you first start because you might not know, am I supposed to use a semicolon here or not? But don't worry too much because the tools are here to help you. So let's see what happens if I say, oh, I don't think I need a semicolon here on line 11. Let me remove the semicolon. And I think I do need a semicolon here on line 9 after the if statement. Well, if I do that and I save program.cs, at this point I would not be able to build or run my program. There are going to be compiler errors, and the C# compiler is going to complain that there is something syntactically wrong with my program. Let's take a look at those problems. I could do a .NET build from the command line. I can also try to do a start without debugging. That's going to do a .NET build behind the scenes, and I can see that errors exist. Let me click on the button to show errors. They're going to appear here in the bottom window of VS Code under the Problems tab. Now, this is another area where things can be a little bit frustrating, trying to figure out what is syntactically wrong with a C# program. So the first obstacle you might face is that sometimes the problems that are listed in Visual Studio Code aren't problems that you can easily get to inside of your C# source code. So for example, this says there's a problem where a semicolon is expected. if I click on that line, I'm going to get an error that I'm unable to open program.cs. Now, it's possible this behavior might change in future versions of Visual Studio Code, but in general, if you see problems that are listed inside of the CS proj file, the project file, don't click on those problems. Instead, look for problems that are listed inside of .cs files, so program.cs. And here's another point of frustration that you might have. If I click on this first problem, which is semicolon expected, it's telling me that this error occurs on line 12. But here's a little tip. You should really try to work through the problems in your source code, starting at the top of a file and working to the bottom. Because quite often you can have an error at the beginning of a file that is creating another error later in the file. And if you try to tackle that later error, you're going to go crazy and pull your hair out, because in many cases what you have is not really an error. It's an error that's caused because of a previous problem. So the situation we have here is actually a pretty good example. There's another problem that is occurring on line 9. This is not an error, it's a warning. And up here, I also want to point out in the editor, I receive little red squigglies when there's an error detected at that location, and I receive little green squigglies when there's a warning at that location. And what I want to do is start on line 9, because that's the first place inside of this file that indicates there might be a problem. And here's the problem on line 9. The C# compiler is smart enough to say, you probably don't want to have a semicolon in this location. You've possibly made a mistake by giving me an empty statement. And what the C# compiler is trying to point out is that when you have an if statement, the C# compiler is trying to figure out what code do I execute when the expression inside the if statement returns true. Well, without the semicolon here, the C# compiler can easily see that there is a block of code that comes after the if statement. And again, this is the start of that block and this is the end of that block. And inside of that block right now is a single statement, but this is the code that should execute this block of code, the entire block of code. So even if I have multiple console.writeLine statements inside of here, all the code inside of that block will execute. The C# compiler can easily see that. But if I have a semicolon at this location, technically what I'm trying to tell the C# compiler is that if this expression returns true, execute the statement that happens between that if statement and the semicolon, so code that would appear here. But there is no code there. There's no statement there, so I have an empty statement. And the C# compiler is trying to tell me that. You probably don't want to check this condition and then execute nothing. You probably want to check this condition and execute the following statement or block of code that you have here. So get rid of the semicolon that appears there. That is a mistake. Now you'll notice as soon as I removed that semicolon, a couple things changed in my problem list, and in fact my red squiggly moved from being on line 12 to being up here on line 11. And the problem on line 11 is that a semicolon is expected. So I do need to have a semicolon at the end of line 11. And you'll notice this entire time there really was no problem on line 12. The problem on line 12 was that my syntax had some issues higher up in the source code file. So we just fixed 2 compiler errors in the program, and everything is back into a state where I should be able to run the program and see hello world or hello Scott, whatever I pass as a parameter. Now, another type of statement that you can have is what we call a variable declaration. So we know from our requirements that ultimately we're going to need to work with floating point numbers. So that is numbers that have some value after the decimal point. And in the C# language, there's some built-in data types that I can use to hold floating point numbers in a variable. So in a statement where I declare a variable, I'm declaring a storage location to hold some value. And just like this parameter here on the main method, every variable declaration consists of a name for a variable and a type. So if I want to declare a variable x to hold a floating point value, I also have to give this variable a type, and the type float in C# can hold a floating point number. There's also a double type in the C# language. This holds a double precision floating point number. So this double type is twice as precise as the float type that I had typed in earlier. It also takes up more storage space, but that's okay. If we want to be as precise as we can, we'll use this double type. And right now I can see a warning. If I hover over the little green squiggly, I can see that X is declared but never used. That's simply the C# compiler telling me, are you sure you really need this X? You're not doing anything with it. So let's try to do something with X. One thing I can do with X is assign a value to it. So I can say that X equals 34.1. That's a floating point value. Or I could just say X equals 34 as an integer value. And I just want to point out that if I were to declare x as an integer, so only hold values that don't use numbers after the decimal point, then I cannot assign the value 34.1 to the integer value because the C# compiler just refuses to automatically convert a number that is of type double to an integer because it's going to lose some information. So let's go back to declaring x as a double. And I just want to show you that another thing I can do is just have this initialization expression immediately after I declare the variable. So double x equals 34.1. Now what I'd like you to try is to define two floating point variables, x and y, and then add those two variables together to place into a result. Then I want you to write the result. So add two floating point numbers and write the result. And by the way, how do you add numbers? Well, the basic mathematical operators in the C# language are addition, which is the plus sign. So I can say x plus 2.1, and I can assign that to another variable by saying some variable equals x plus 2.1. There's also subtraction with the minus sign, multiplication with an asterisk, and division with a slash. So I want you to try to add two numbers together and right line the result. Let's do some addition. What I want to do is add another floating point variable to the program. Let's name it y and set that equal to 10.3. And then I want to add x and y and place that into a result. But before I do that, let me introduce you to another feature of C# and a new keyword known as the Var keyword. So anytime you have an initialization expression like 34.1 and you're assigning that value to a variable at the same time you're declaring the variable, you can take advantage of a feature in C# known as implicit typing, and you can do this with the var keyword. Essentially what you're telling the C# compiler is that I know you can figure out the type of this variable based on the context and what's happening in the code. I know you'll be able to figure out that x is a double, and indeed if I hover over x with the mouse, I can see it really is being treated as a double. But the benefit here is that I don't need to provide an explicit type every time I create a variable. Now, some people love the var keyword because they think it keeps the code clean and simple. Other people do not like the var keyword. They want to see explicit types everywhere through the program so they don't have to guess what the type is. So feel free to use the var keyword or not use the var keyword. I prefer the var keyword myself, so I'm going to be using it a lot during the course. But I do just want you to know that this is still a strongly typed variable. So this is not like the var keyword in JavaScript, where I can go on to say on the next line of code that y equals a string. That's going to be illegal because I cannot assign a value of type string into a variable that can only hold a double, a floating point number. So that's illegal. Another place I could use the var keyword is when I define a result. But in order for the var keyword to work, I have to have some initialization expression. I have to say that result equals something. Otherwise, when the C# compiler looks at this line of code, there's not enough information to tell the compiler what is result. So that's the first error that you see in the pop-up window. Implicitly typed variables must be initialized. When you're using the var keyword, you're allowing an implicit type for that variable. But if I say result equals x plus y, and then a semicolon, now the C# compiler knows that result is going to need to be a double because we're adding two doubles together. So obviously the result has to be placed into a double. If I were to try to place that into an integer, that will be an error because an integer doesn't have enough precision to hold a floating point value. If I tried to place it into a string, that's an obvious type mismatch is what we would call that, trying to put a number into a sequence of characters. So I'm going to leave this implicitly typed as a double using the var keyword. And then what I want to do is a console.writeLine and display the result. So here's a little quick tip in Visual Studio Code. Visual Studio Code does include some code snippets for common expressions and common statements that you write in the C# language. So one way I could do a console.writeLine is to type out console.writeLine. But another way to add a console.writeLine statement is to type just CW. And I can see in this pop-up window that CW is going to be short for console.writeLine. And in order to expand the snippet, what I do is just press the tab key, and I now have a console.writeLine, and we're using the full namespace to get to the console, which I don't like. I would prefer just console.writeLine. And now, what does writeLine actually take? Does writeLine require a string, like the string that we're passing down here? Well, no, it turns out that writeLine can take any number of parameters of any type. And we can pass in integers and floating point values and strings, and we'll talk about how that works a little later in the course. For right now, I just want to say result, And this should print out our result. Let's test it real quick. I want to start without debugging. I'm going to watch the output, scroll by down here in the debug console, and I see the result, 44.4, and hello, Scott, that looks correct. Now, if we look back at our requirements, we know we're going to have to do an averaging of numbers. But according to the requirements, we really don't know if there's going to be 1 grade or 10 grades or 1,000 grades or 0 grades. No one said your students will produce exactly 10 grades. So we're going to have some sort of collection of floating point numbers that we can manage and that can grow as we add more grades. Obviously, we don't want to do that by declaring a variable for each grade because we don't know how many grades there's going to be. And that's where we can turn to a collection, like an array. The parameter that is passed to this main method is an array of string. It's named args. If I wanted to declare an array of floating point numbers, I could use that same syntax, which is double, and then square brackets, and call this variable numbers. And once I do that, I could walk up to numbers, and I could try to read values out of numbers by going to numbers sub 0. Just like down here, we have an expression that goes to args sub 0 to get the first string in the args array. Numbers sub 0 would be the first element in the numbers array, so the first floating point number. And I could also assign a value to that position. So if I wanted to write into the first position there, I could say that number sub 0 equals 12.7. As you can see though, I currently have an error. And if I hover over the red squiggly, I will see that I'm using an unassigned local variable numbers. So the C# compiler is not going to allow you to use an unassigned local variable because that typically leads to errors inside of a program. You're doing something with this variable that you've never assigned to. In this case, that array doesn't actually exist. All you have is a variable that is pointing to an array that doesn't exist. And we'll talk a little more about pointers and references later in the course. The same is true with explicitly typed variables, by the way. So if I just say double x, so I know x is of type double, but then I try to use double in some sort of expression, like x equals x plus 3.1, that is also going to be a compiler error because I haven't assigned a value into x. So I need to initialize variables one way or another. And the way to initialize an array, if I don't already have an array available, is to create a new array to assign to this variable. And I do that with the new keyword. So you can think of this as creating a new array, instantiating an array, and I have to use an expression that says this is going to be an array of double, and I also have to provide a number inside of the square brackets that represents the size of that array. So the syntax where I just have double and square brackets, that's fine for declaring a variable and for defining a parameter. I'm just saying, yes, this is going to be an array. I don't know the explicit size of that array, and that's okay. But down here, when I'm creating an array, I have to provide an explicit size. How large is this going to be? How many numbers is it going to hold? Let's use the value 3. So our array can now hold 3 floating point numbers. And once I have this full initialization expression here on the right-hand side, once again, I can use implicit typing to simplify these lines of code. And now what I'd like you to do is add 2 more numbers into the array so there are 3 floating point numbers inside, and then compute the sum of those 3 numbers and write out the result. In the next clip then, I want to introduce you to some new syntax that will hopefully make those tasks easier. Let's finish populating the array. So I'm going to add number sub 1. Let's make that a 10.3 again, and number sub 2 equals a 6.11. And now one way I could add the result is to say result equals numbers sub 0. And then on the next line, I could say result equals result plus number sub 1. And then of course I could say result equals result plus number sub 2. And then we could console.writeLine our result. Let's do a quick run to see if we get the right answer. So I'm going to save program.cs, start without the debugger, and down here in the output window, I can see 29.11, which seems like that's an answer that's in the right ballpark at least. So now let me show you a few things that can simplify this code. Let's start with the array initialization. If I know exactly what values are going to go into this array, so I know there's going to be a 12.7 and a 10.3 and a 6.11, I don't have to write these statements on separate lines like this. Instead, in C#, I can use what's known as the array initialization syntax to go ahead and tell the C# compiler, please put inside here the values 12.7, 10.3, and 6.11. So the syntax is simply using curly braces to denote a series of expressions that are separated by commas to say, I want a new array that can hold 3 numbers, and by the way, here are the 3 numbers. And notice if I try to add a 4th number into the array, I'm going to receive a compiler error. Sorry, you declared an array of size 3, but you're trying to put 4 numbers inside. So one solution to that problem is that when I know exactly what I'm putting into the array, I can once again rely on the C# compiler to do the right thing. So instead of saying that I want a new array of double that can hold 3 items, since I now have an initialization expression, I can leave the number out of the square bracket so I don't have to provide an explicit size. Instead, the C# compiler will figure out what size I need to hold these values. And now, I don't need to write these 3 lines of code. So perhaps this code is a little bit easier to understand. Either one will work, but I want to use the code that is the most readable. Now, once I have this initialization expression, it turns out I also don't need to explicitly tell the C# compiler that this is going to be an array of double. The C# compiler can both figure out the type, the underlying type of the array, and the size of the array. So I can remove the keyword double here and just basically tell the C# compiler, look, I want a new array. Here's the values it's going to hold, and the C# compiler is going to figure out the rest. If I hover over numbers, I can see, yes, it's an array of double. So these are just little nice things that the C# compiler can help you with. You don't have to write so much code and be explicit about everything. So here's another shortcut by the C# language. Anytime I want to take a variable and add a value to that variable and store the result back into that variable, there's a shortcut expression I can use. So instead of saying result equals result plus numbers sub 1, I can say result and then use an operator known as the plus equals operator to say basically add number sub 1 and store the result back into this variable. So the line of code I had there previously and this line of code, they will do the exact same thing. And I can do that also down here. I can say result plus equals number sub 2. And now that I've added an additional number into the array, I'm not computing the correct result. And obviously it's going to be impossible to write code like this, where I address each member of the array individually, number sub 0, number sub 1, number sub 2. That code is going to be impossible to write if I do not know the size of the array when I'm writing the code. And that would be the case with an array parameter like args here. I don't know how many args are in that string array when I'm writing this code. Yes, I can check this length property at runtime to find out how many elements there are, but writing code like this is impossible. And this code also contains a lot of duplication. Essentially, what I want to do is add in a number to my result for each number that is in that array. And when I say for each, that's important because there's a number of looping statements that you can use in C# to loop over and visit each item in a collection. Later in the course, we'll talk about more of the looping constructs and looping statements that are available, but for right now, I want to show you that if you want to do something for each number in the numbers array, you can write what's known as a for each statement. So let's back out a few of the things we've done. I just want to say result equals, and let's say a 0.0. And now instead of explicitly adding these numbers, I want to write a for each statement. So the for each statement consists, first of all, of the for each keyword, and then inside of parentheses, I am first of all going to declare a variable that will hold the value of each item that is in the collection that I am iterating over. And I tell for each that I want this variable to work across the values that are in numbers. So I'm saying for each double number in numbers. Behind the scenes, the C# compiler will generate instructions that will visit each number that is in the array, so 12.7, then 10.3, and then 6.11, place that value into this variable number, and then execute the code that is inside of the for each statement. How do I place code inside of a for each statement? Just like how I place code inside of an if statement. So I use an opening curly brace and a closing curly brace to say for each number, execute the following code. What I want to do here is add my number into the result. I want you to try that, but before you go, I also want to point out that this value, number, this variable, has to be typed appropriately. So if I try to say, pull out each string that you find in the numbers array, the C# compiler is smart enough to say, sorry, you're operating on an array of double. You're trying to assign a double to a string, and that's not going to work. So this has to be of type double. That would be explicit typing, but once again, I can use the var keyword to say, create a variable called number, give it the appropriate type, and just place each value inside. Now see if you can write the code to still compute the correct result. Inside of our loop, all we need to do is add each number to our result. So that could be an expression like result plus equals number, and that will allow us to compute the proper result. Let me run this without the debugger. Control F5 will do that, and I can see the result is 33.21. And what we've been doing is taking these little steps, and what we're working towards is the ability to store grades in a grade book and then compute the average grade. So now we can see how to loop through a collection, how to add up numbers, and I'm sure you'll be able to figure out how to divide one number by another number. But there's one big limitation of the code that we've written. The requirements don't tell us how many grades that we'll need to store. Will there be 1 grade, 10 grades, 1,000 grades, or 0 grades? We don't know. And when we're working with arrays in the C# language, we need to create arrays with a specific size. So I need to create an array with these 4 numbers, or I need to initialize an array that can store 10 floating point numbers. And that's not going to work well if we don't know how many grades the user might give us. Fortunately, the .NET libraries provide an answer in a namespace system.collections.generic. That namespace contains a number of classes that we can use that are data structures. Data structures like a stack and a queue, if you've heard of them. And there's also a simple data structure named a list. A list allows me to keep a list of things around, like a list of floating point numbers. And the way I would use a list variable would look like this. Let me use some explicit typing to say that I want a list of floating point numbers. Let's name the variable grades. And before I can use this list type, there's 2 things I need to do. First of all, when you see this error message that the type or namespace list could not be found, are you missing a using directive or an assembly reference? That is the C# compiler telling you that I don't know what this is. I don't see this type, this class, or this thing that you're trying to use anywhere. And sometimes this is simply because the type that you want to use is in a namespace that the C# compiler is not looking into. So every class in the .NET framework is going to be in a namespace of some sort. Namespaces help to reduce the collision so that if I write a class called list and you write a class called list and the .NET framework has a class called list, there's still an easy way to differentiate the 3 because the 3 will essentially have different names as long as they're in different namespaces. An example would be this console class. We saw earlier when I used a code snippet that this class is actually named system.console. System is the namespace that the console type lives inside of. But I don't have to explicitly say system. I can do this. This is legal C# code. But I can remove the system namespace as long as I have a using statement to let the C# compiler know that it should be looking in the system namespace for any types that I use. So now I can use anything inside of system, and there's quite a few types inside of the system namespace, but list is not one of those types that is in the system namespace. Now sometimes it's very easy to find the namespace and the tools are going to help you. So if I place my cursor directly on that list where there's a red squiggly and I press Control and period, this is bringing up a menu that will help me try to fix this particular error. So the first fix in this list of fixes is to add a using statement to this file for system.collections.generic. I want to highlight that entry and I want to press enter. And that is at the top of the file going to add using a system.collections.generic because that is where the list type lives. It is technically system.collections.generic.list. But I still have an error on this line of code because this type requires 1 type argument. What is a type argument? Well, there's certain classes and types in the .NET libraries that require you to provide some additional information about how you're going to use that particular type. So for example, when I want to use a list, in order to use that list, I have to describe what types of things I'm going to put into that list. Are they going to be invoice objects or employee objects or integers or date times or strings or double precision floating point numbers? In this case, what I want is a list that will only store double precision floating point numbers. And the way I describe that is to use an angle bracket and to put the type double here. So what I'm saying is that I have a variable named grades, and grades will be typed as a list of double. So just like the previous variable is an array of double, this is a list of double. It's just the syntax is a little bit different. And yes, I can also use the var keyword here if I have the right kind of initialization statement. So again, grades, before I can use grades, I need to initialize grades. And once again, I will need to use the new keyword to say, I want this variable to point to or refer to a new list of double. Now, yes, the initialization syntax for an array is a little bit different than the way we initialize most of the other types that we use on a day-to-day basis. And what we're seeing here with the new list and the parentheses, this is a syntax and a format you'll become accustomed to because this is how we use most of the types inside of .NET. The parentheses almost imply that I'm invoking a method here to create this list of floating point numbers, and in fact, as we're going to see in the next module, that really is what is happening. There's a special method that can create my list of double. And at this point, I can use grades very much like an array with the addition of being able to add things into it. So unlike an array, which has a fixed size and it can be difficult to add new things into an array, it's possible, but it's just not very efficient. A list is implemented from the start as this dynamically sizable collection that you can just keep adding and removing things from. So notice when I want to add something to a list, I have to add something that is of type double, which makes sense. So I can say, let's add the value 56.1. And then just like an array, I can also index into a list. So I can say, let's look at the first element in that list. What is it? It's grade sub 0, just like I would go to an array sub 0 to look at the first element. So arrays and lists share a lot of the same behaviors and features. It's just that a list is dynamic. I can add new things into it. So up here, let's change this to use implicit typing. I'm just going to say var grades equals a new list of double. And in fact, just like with an array, I can provide an initializer if I just want to go ahead and add some values into that list right from the start. So now my list contains the same 4 numbers as this array. It's just that with this line of code, I'm adding an additional number. So in addition to sharing some of the same initialization format and being able to index into a list, I can also use a for each statement to iterate or loop over that list. So instead of saying for each number in numbers, I want to say for each number in grades. And if I run this program with Control F5, I will see the result, 89.31, which looks about correct. And now what I'd like to see you do is compute an average for all the grades that are now stored in the grades list. Now when you do that, I don't want you to just take the result and divide it by 5 and hardcode the value 5. What I want you to do is figure out how to find the number of items that are in this list. Just like an array has a length property, a list has a property that will tell you how many things are stored in the list. It's just that that property is not called length. But see if you can use the tools or the documentation or the IntelliSense that pops up after you press a period to figure out what you can use to compute the average. Let's compute an average grade. And before I take that step, let me also delete this line of code that is defining a numbers array. We're not using that anymore. We just want to compute the average grade. So at this point, by the time we reach line 18, we now have a total sum of all of the grades. All I need to do is divide by the number of grades to compute the average. So I could say that result equals result divided by, and here's how I find how many things are in the array. If I just scroll through the IntelliSense list here, I can see a count. And if I were to look it up in the documentation, yes, count would say this is how many items are in this list. And just like with addition, I can also say divided by and equal grades.count. So divide the result by grades.count and then assign that value back into result. At this point, if I run the program again, you can see I get the result 17.862, which sounds roughly correct. And if I wanted to make this a little bit fancier, what I could do is use some string interpolation like we did before to build a more proper descriptive output for the program. So let's say that the average grade is, and again, inside of curly braces, which in this case is not describing a block of code or denoting a method body. When I'm doing string interpolation by defining a string that has the $sign before the opening double quote, the curly brackets allow me to poke data into the string at the appropriate location by writing simple expressions. If I do a quick test by running this program again, we should have the same result, which is 17.862. But now we're just not spitting a number out of the program. We're actually telling the user that the average grade is, and here's the following number. Now, what if I wanted to do some formatting on this? The requirements didn't say this, but typically you're going to have some sort of formatting requirements for your output. So if you're displaying an average, you might want 1 digit after the decimal place or 5 digits after the decimal place. It all depends on how much precision your business needs for this particular number. Now, I'm not going to give you an exhaustive list of all the different formatting options that you have with the C# C# language, there are probably 24 ways to format this number, but I can tell you if you go to your favorite search engine and search for C# format floating point number, you'll find lots of different examples that ultimately boil down to this. When I want result output in a specific format, I can apply a formatting string that looks something like N3. This is a way of saying that I want this formatted as a number with 3 digits after the decimal place. Let's try N1 actually, so 1 digit after the decimal, and now a Control F5 will give me the result, 17.9. So there's dozens of these little formatting specifiers that you can add to format numbers, to format dates, to left align and right align strings. There's lots of options, and I'll let you discover some of those on your own. In this module, we learned a few of the basics in C#. We learned how to declare variables. We learned how to write statements like looping statements and if statements. We learned a little bit about arrays. We learned a little bit about a list. And now we're already looping through a list of floating point numbers, a list of grades, and we're computing an average grade. In the next module, we want to build on the code that we have and start to build a better abstraction for storing these grades and computing results. We'll do that by defining a class with the C# language.